We're getting ready to prep for algebra with this section. And exponents, for the most part, you probably have an idea what they are. For example, if I write 2 to the third power, I know that that's 2 times 2 times 2. So when you multiply that all out, you get 8. So in the expression, when we have 2 raised to the third power, the 2 is called the base, and the 3 is called the exponent. Some people also call that the power, which is fine. Either exponent or power will do, as long as you know what to do with it. So in general, if I have x to the third power, whatever x is, I'll have x times x times x. So let's do a couple of examples real quick. If I write 2 to the fifth power, that's 2 times 2 times 2. 5 times, you'll see 5 2's. And then when you multiply it out, you'll have 4 times 2 times 2 times 2, which will equal 8 times 2 times 2, which is 16 times 2, which is 32. Now be careful here. Look at this one. Negative 2 to the second power is negative 2 times negative 2. And when you multiply a negative times a negative, you end up with a positive. So the negatives went away in that example. Now imagine something like this. If I gave you this problem to do, what would you get for your answer? Well, forget about the 0 for now. I'm more interested in what part of this thing I would do first. And the first thing you should do, according to PEMDAS, remember this thing? We have the highest level or the highest order of operation is the exponent. So I would have 0 minus 16, and that equals negative 16. So look, this thing right here that I wrote is equal to just negative 2 to the fourth, because 0 minus anything is just that number itself. Or well, you get the idea. So notice that when I write negative 2 in parentheses to the fourth, that's slightly different. And that will then, in this case, you will get 4 times negative 2 times negative 2. And that will equal negative 8 times negative 2. This case, it's positive 16. So on the one hand, the negative was not eliminated. On the other hand, it was. So how do we remember? When I did this one, here's what you do. Think of that thing as a minus sign, so that you would do the exponent before you would do the minus, and there you would get a negative 16. On the other hand, the parentheses around the negative 2 means you're supposed to take the negative 2 quantity and multiply it by itself 4 times. So that's why you get a positive 16. The negatives cancel in that case. Now remember, with PEMDAS, you have to be careful, because multiplication and division are the same. So sometimes I'll write this weird symbol. I'll write an M with a D over top of it and an A with an S over top of it, so that you know that multiplication and division are equal, and so are addition and subtraction. Now we'll need those. You'll always use the order of operations for everything you do in math. We'll do a bunch of examples, but let me hit up the exponents a little bit more. Just a few examples with those. So I'll start with 3 squared plus 5 squared. Here you have exponents and addition, so you would simply do the exponents first. 3 to the second, 3 times 3 is 9. 5 times 5 is 25, and together you get 34. This one's probably easier to do than the one where it had a 0 in the place of the first 8. Here you would do the exponent first, so we get 8 minus 64. In case you need reminding, we don't do subtraction like this. We do 8 plus a negative 64. Now, negative 64 is the dominant number, so I know my answer is negative. And then we finish this off by always taking the bigger minus the smaller. You always do a subtraction when the signs are opposite. So to accomplish this, I'll have to borrow. 14 minus 8 is 6. So I'll end up with negative 56. Now we'll move on to some other order of operations types of problems. And the rest of the examples that I do, they're all just going to be examples of different kinds of complications that may arise. So let's start. On this particular problem here, you should do the parentheses first. You always do parentheses first. So I'll do negative 9. Now inside of there, 5 minus 17 is negative 12. At some point, you're going to have to become more comfortable with doing those without breaking it down into more pieces, because it will overcomplicate the problem. So I'll leave it to you to figure out how you get the negative 12. Now, on the other hand, that negative 6 is really not in parentheses, or, well, it's in parentheses, but there's nothing to do inside of there. The only reason the parentheses are there in that case are to separate the negative sign from the division sign. So let's see what is next. Now that we know that the parentheses are done, even though you see them here, they're finished, I'm going to put a dot to remind myself that that is multiplication. Now, let's do the multiplication first, because remember, multiplication and division are equal in order, except we do whichever one comes first. So when I do negative 9 times negative 12, I'm going to get a positive number. That will be 108. Now you have a positive number divided by a negative number, so you get a negative. And to figure out what that's going to be, I'll take 6 and go into 108. 6 will go into 10 one time. 6 will go into 48 8 times. And we end up with negative 18 for the answer. Next, let's try 7 plus 5 times the absolute value of 1 minus 3. Now remember, there's a multiplication after the 5. The 1 minus 3, the absolute value you can think of as parentheses, so I'm going to do that first. Although it doesn't always work the way parentheses do. Nonetheless, you can treat it as such for the purposes of these problems. I'll get 5 times the absolute value of negative 2. To finish that off, the absolute value of negative 2 is just 2. Then I'll do the multiplication next, so I'll get 7 plus 10, and that will equal 17. Next, 3 squared times 2 cubed minus 10 minus 2 divided by positive 4. So this time I'll do the parenthesis first. So I'll get 3 squared times 2 cubed minus 8 divided by 4. Then I'll do the exponents next. So 3 to the second power is 9, 2 to the third power is 8. Be careful, students sometimes put a 6 there because, I don't know, they confuse what they're doing. 2 raised to the third power is not 6 because that's 2 times 2 times 2. Now, in this situation here, I can actually do multiplication and division at the same time because they're separated by a lower order of operation, and that's the minus sign. So I'll do those at the same time. I'll get 72 minus 2. And that is equal to 70. Next, I'm going to do negative 5 times the absolute value of 16 minus 25 minus 3 times 10. And so once again, I'll do the absolute value first since it's like parentheses. 16 minus 25 is negative 9. Now the absolute value is not done quite yet. Let me do it in the next step. Negative 5 times positive 9 minus 3 times 10. And now I'll go ahead and do the multiplications. I'll get negative 45 minus 30. And remember, to do this kind of a problem, you should be able to do this in your head fairly quickly. But if you're still working on this, remember this is the same as negative 45 plus a negative 30. Since you're adding two negative numbers together, you're going to get an even more negative number. I'll get negative 75. Next, I have 56 divided by negative 7 minus 3 times 8 minus 10 squared. So in this problem, you should be able to tell me that there's only one set of parentheses I need to deal with. The negative 7 in parentheses is no big deal because it's just a holding place for the negative sign. So I'll just write down that part since I'm not going to do anything with it yet. The 8 minus 10 is what I'm talking about. That's going to be negative 2, and that'll be raised to the second power. Next comes exponents. So the negative 2, if I square it, that'll be negative 2 times negative 2. That will be positive 4. So now I'm in a situation which I've been before. I've got a division and a multiplication. I can do it at the same time because they're separated by subtraction. 56 divided by negative 7 is negative 8. Minus 3 times 4 is 12. Use the example that I previously did if you still need help with this. This will be negative 20. But if you're starting to get comfortable with it, notice that the 8 and the 12 add up to 20, and since it was all negative, you know it's negative 20. All right? On we move then to 2.1, and this is where we're going to start doing algebra. And whenever you start to deal with algebra, you start to talk about letters standing in for numbers. So we'll start right off the bat with something like that. Here's our first example, will look like this. Evaluate, and I've got 4 expressions here. A, B, C, and D. So this is 4 examples in one. I have A plus 8, A minus 12, A divided by 8. I guess I should give myself a little more room here. And finally 3A. All of these, evaluate all of these things when A equals 16. So if we look at part A, here's what I'm going to do. Now that I know the value for A, I'm going to substitute that into the expression. So A plus 8 is equal to 16 plus 8, because I know that A is 16. And that's 24. So each of these you're going to get a number. For part B, we're asked to do A minus 12. Once again, I'll replace A with 16. 16 minus 12 equals 4. For part C, I'm doing A divided by 8. So I'll replace A with 16. 16 over 8 is 2. And then finally, 3A. Whenever you see 3A, that's 3 times A. So that means when I replace A with 16, I'll make this 3 times 16, which equals 48. So whenever you're dealing with these letters, you may not always be told what the numerical value of the letter is. So sometimes we have to be able to manipulate just letters. But right now we want you to get comfortable with the idea of having expressions with letters in them. And the letters usually will be referred to as variables because the letters may have different values plugged into them. This, for example, this last example, I could have put another value for A in there, and we could have had a whole new set of problems to do because you would have substituted a different value in for A. Well, let's do some examples here. Same kind of an example that I previously did. So I'm going to say to evaluate. And this time we only got 3 expressions. Here I have a 4c plus 8, 8c minus 15. That's part B actually. And C would be 5c over negative 9. And I do this when, let me make that 9 more 9-like, when C equals 9. All right, so let's take a look at each of these. 4c means 4 times C. So when I replace C with 9, I'll have 4 times 9 plus 8. Now, once you have all the numbers, you follow the order of operations. 4 times 9 will be 36. And that should equal 45. Next, 8c minus 15. That's 8 times C. I'll put the 9 in for C. And that will give me 72 minus 15 should be 57. And then part C, we have 5c over negative 9. That equals 5 times 9 divided by negative 9. 5 times 9 is 45. Now you have a positive divided by a negative. We know the answer is going to be negative. And then you should know from your elementary school days that 45 divided by 9 is equal to 5. Now for some of you that are thinking about, I could have done this in an easier way, that's okay. You can if you wanted to. If you look back, take a look right here. If you know to cancel, I could have canceled these 2 9s there, like so, and it would have left a 5 divided by negative 1, and that's negative 5 also. Let's do some more examples. Evaluate 7s minus 8t plus 11. So now you have two variable quantities, if you will. Let's evaluate it. for s equals 5 and t equals negative 6. So let me write the expression again so that I can do my work underneath of it. 7s means 7 times 5 because s is 5. And then I have minus 8 times t, that was negative 6, plus 11. Let me give you a warning. Substitute negative numbers in parentheses. So what I'm talking about is right here, this negative 6. Do you notice I put it in parentheses? If you don't, it'll look like you're subtracting 6 and you won't know to multiply by it. So now let me go ahead and do the steps. The only order of operations that I have are multiplications, subtraction, and addition. So I'll do the multiplications first. 7 times 5 is equal to 35. 8 times negative 6 is equal to negative 48. And then the double negative, we talked about that already, becomes a single positive. And now I'm ready to just add straight across. If you need help, you might want to do this. 35, 48, 11. Just make sure you keep your columns in order. Let's see, I think that's 94. Next example, here I have negative 7w minus 8z minus 19. So I want to evaluate that. For we have w equals negative 9 and z equals negative 11. So let me plug those things in. So negative 7w minus 8z minus 19. I'll replace w with negative 9, do it in parentheses as I suggested. Then I do minus 8 times negative 11, and then minus 19. Now in the first piece, I see negative 7 times negative 9. That's going to equal positive 63. 8 times negative 11 is negative 88, and then negative 19. Let me fix this all up for the next step. Double negative becomes one single positive, and then I can do plus a negative 19 for that part. Let me add it all up and see what we get. 63 plus 88. I'll get 151 plus negative 19. You know this answer is going to be positive since the dominant number is the positive one. But to get the answer, I'll have to do 151 minus 19. So I'll carry or borrow a 10. 11 minus 9 is equal to 2. 4 minus 1 is equal to 3. And then the 1 was solo, so I have 132. Now we're ready to start working exponents with variables. So if some of the questions are as simple as this, you could be asked to rewrite that in exponential form. So can you rewrite it with an exponent? Well, you see that there are 4 u's, so you know that this should be u to the 4th power. And that's really all there is to that. Next, we might see something like S times T times T times T. So here we see two S's, so I have S to the second power, and I see three T's, so T to the third power. Now, it's probably not a bad idea to put a dot between them like that, but you don't have to, because it's understood that it would be multiplication if you wrote nothing at all. But whatever you look at, make sure you group the S's together and the T's together. Let's try another one. Here I'm going to do A times B times C times. This will be long, but it's not as bad as you think. Now, you can go and gather up all the A's and everything. Remember, multiplication is something that we call commutative. That means I can rearrange the order. So if I wanted to, I could take all of the A's and put them first. So I counted 1A, 2A, I counted 3 A's, so I've got them, and I'm going to put them in the front. And then I'm going to start moving on the B's. So I have 1B, 2 B's, 3 B's, 4 B's. So I have 1, 2, 3, 4. And then I have 1C, 2C, and 3 C's. Now I was allowed to do that because of commutativity. Now I can go ahead and make each of these in exponential form. So I'm going to have A to the third times B to the fourth, I see 4 B's, times C to the third. And just to make a note, that expression without the dots is also correct. So you don't necessarily need to put those dots in there. The multiplication is understood. Next, let's do negative 11 times n times n times n times n times t. Here then, I only see one 11 there, so I'm going to have negative 11. But I will see 4 n's, so I'm going to write n to the fourth and then times t. Or if you wanted to, I'll probably be dropping the dots later on in the course as I feel you become more comfortable with what we're doing. Now let's go back to evaluating expressions for different values. So I'd like now to evaluate x squared for x equals 2, x equals negative 2. So for part A, I'm just going to have 2 to the second power, and everybody knows that that's 4. For the second part, it's important that you substitute the negative 2 inside of parentheses so that you know how to handle this next part. Now this is not negative 4. We know that negative 2 times negative 2 is actually positive 4. Let's move on. Evaluate negative 5c to the fourth for c equals negative 3. So I'm going to have negative 5. I'm going to replace c with negative 3 in parentheses and raise it to the fourth power. Now to do negative 3 to the fourth, you should probably do this. As you progress through the course, you'll probably be able to do this in your head. But if you see, the negative 3 raised to the 4th power is negative 3 times itself 4 times. Negative 3 times negative 3 is 9. And then 9 times negative 3 is negative 27. And that will end up, negative 27 times negative 3 is positive. So this equals negative 5 times positive 81. You know this will be negative because a negative times a positive is negative. 5 times 81, if you can't do it, you'll have to multiply it out longhand in some sort of way. But I happen to know that it's 405. Next, let's evaluate negative 5x cubed for x equals negative 3. So I'm going to get negative 5 times negative 3, put the negative 3 in parentheses, cubed. Now, to do that exponent, I have to do negative 3 times negative 3 times negative 3. That's negative 3 to the 3rd power. Negative 3 times negative 3 is 9. And then 9 times negative 3 is negative 27. Oh, I got a little ahead of myself. There is, and that's not the finished problem. Now, this is going to be negative 5 times negative 27. Negative times a negative is positive, so I don't have to worry about writing a minus sign. And then 5 times 27, which is what I want to do next. 5 times 7 is 35, and I'll put a 3 up there. 5 times 2 is 10, plus 3 is 13. So I have positive 135. And now we're just going to do more complicated examples. They're not more difficult per se, but they are more complicated. As long as you stick to your rules, you shouldn't have a problem with it. Just go a little bit slower if it gets more complicated. So let's take a look at what we have. I want to evaluate 2h squared j to the 3rd power when h equals negative 4 and j equals negative 3. So remember to substitute those inside of parentheses. So when I do my 2h squared j cubed, I'm going to replace the h with negative 4, and I will raise it to the 2nd power. And then I'll have the negative 3 and raise it to the 3rd power. So you can see that I've replaced the h and the j now. Now I've got to take care of the exponents first. Negative 4 squared is positive 16. Remember, that's negative 4 times negative 4. However, negative 3 cubed is equal to negative 27. So remember, negative 3 times negative 3 times negative 3. Now, since I have multiplication followed by multiplication, I can go left to right. And I have a positive times a negative, which is negative. And now let me go ahead and do the multiplication. 7 times 2 is 14, carry the 1, 21, 22. 2 times 2 is 4, and then 2 times 3 is 6. Looks to me like my final answer will be negative 864. If any of these, if I go too fast for you, don't forget that you can pause the video whenever you want to in order to stop the screen from moving. Let's do another example. Here I'm going to evaluate u squared plus 4u plus 9 when u equals 7. So when I do that, I'm going to get 7 to the second power plus 4 times 7 plus 9. I'll, of course, do the exponent first. The 7 squared I'll do first, and I'll get 49 plus 4 times 7 plus 9. 4 times 7 is 28. And I think we're going to have 77 plus 9 equals 86. Now, let me do the same example again. This time, I'm going to let u equal -7. So when I replace the u, I'm going to replace it with a -7 in parentheses. -7 to the second power is positive 49. Four times -7 is -28. Now between 49 and -28, 49 is the dominant number. And when I do 49 minus 28, I'm going to end up with 21. And the answer for this one is 30. Notice that it doesn't conceivably look even related to the previous problem. It's not the negative of it or anything like that. So the answers can be wildly different once you plug in different numbers, of course. Let's evaluate. This time I'm going to have 2x squared y minus 3xy squared minus 65. And I'm going to do for x equals -1, y equals -5. So I'll replace x with -1 in parentheses, and I'll replace the y with -5 in parentheses. So let's go ahead and do that. I'll rewrite it just to make it easy to follow. And don't be afraid to give yourself a lot of space so that you can match up where the substitutions are right underneath of the expression itself. So I'll put a -1 in parentheses wherever I see an x, and I'll replace the y with a -5. All right, now let's take care of the exponents first. -1 to the second power is just equal to 1. -5 to the second power is positive 25. Now I have a series of subtractions and multiplications, so I'll do the multiplications first. 2 times 1 is 2. 3 times -1 is -3. 2 times -5 is -10. -3 times 25 is -75. And then my last step, I'm going to clean it up so that it follows the way we do addition and subtraction in this course. I'm going to rewrite it slightly like this. The -10 is fine, but the double negative becomes an addition sign. And then -65 I should think of as plus a minus 65. And let's go ahead and go from there. I'll start with the negative 10 plus the 75. I'll go from left to right. Negative 10 plus 75. Well, the dominant number is 75, so it's going to be, that part's going to be positive. So when I do just this part right here, just do 75 minus 10 and you'll get 65. But whenever you see this, rejoice a little bit, I suppose, because 65 plus negative 65 is 0.